Hello and welcome back. This is part 3. I went ahead and put the tuning condenser back on. I still need to solder the negative straps back down. I soldered in the wire for the lamp. Paint's all pretty much cured. What else did I do? The document, I told you that. I put the caps in and I wired them up. The person that had done this has been worked on several times. At some point this was put in, this multi-cap. It's labeled to have 4 sections at 15 microfarads. These two were wired together to make 30 to replace the 18. The other two were to replace the 8 and the 10 in this multi-cap here. The ground, was isolated, and they did have it isolated in their whomever put in a plastic piece, so it replaced the isolation here. This one had a separate ground lead, so it wasn't grounded to the chassis, so it all worked out that way. This is drifted and it's leaky. So this was actually running at 50 instead of 18, which is pretty high. These two are running at 26 each, but again, they're leaky. So that was not a bad thing. I don't know how old this was. It had a cardboard cover on it that made it look like it was pretty old. So I went ahead and wired this back in. So the 18 is here. I replaced it with a 22. The 8 and the 10 were replaced with an 8 and a 10. The 10 was actually only 50 volts, and that one is positive to ground. So when I did this last night, I just out of habit went ahead and put the negative to ground, and I had to redo it. Unfortunately, I'd already cut the wire, so I don't feel like pulling that out and pulling it out and putting a new wire on it. So I went ahead and traced all this out here. So the 18 connects up to, what does it connect to? The 18 connects up to the blue with white tracer, which comes out of the 5 volts on the transformer, and it connects to the center tap on the main secondary, which is a yellow with green tracer. So I went ahead and double checked with that. The 8 microfarad here connects up here. This is just a tie point on this block, and goes back down to this point here where it connects into the primary of the secondary IF transformer, and that's correct. I replaced, they had a 22, they had this one completely disconnected. It was actually still liquidy, and I went ahead and drained that out, cleaned it, and restuffed it with a 22 and hooked that back up in there, and removed the 22 that was in there, which is fairly recent, but I just did it anyway, just for good measure. It was an Ichicon, so I assume it would probably still be good. So I have a CS in there, so it's 20,000 hour. Hopefully that won't go bad for a very long time. Underneath here, a couple of the caps that had been replaced over the years. Some were old, some were new. I did leave this 0.051 in here. It's a General Electric. It's fairly new. It's only rated at 200 volts, so I'll go ahead and measure the voltage across this. If it's close to 200, I'll swap it out with a 630. Only because I'm running low on 0.05s. Let's see, that one I replaced, and this one. There's a cap here that goes over the coils, and I'll put that back in. I had to replace a couple of the resistors. This 1 meg resistor here was reading at 1.6 megs, so that's pretty much out of tolerance. There's a 51K here that was running at 78, I think. The paint on this one had worn off. It wasn't melted, but I wasn't sure if it was a 51 or a 71. The schematics, or the change document, shows that a bunch of these were swapped out supposedly in run 2. However, everything else in here seems to be as if this was a run number 1, but according to the stamp on the back, which I can really only read with the LED flashlight, this is a model 38.5, code 121, run 13. But according to the change document, this should have newer IF transformer in it, and it doesn't. So very strange that this would be as high as a run 13 and not have hardly any of the changes that were documented in the writer's change documents. Like I said, the components that are in here, with the exception of this resistor, I guess they were having a problem with the 71K resistor causing, what does it say, 70 ohm change to 51 to improve the performance of the oscillator circuit on the shortwave band. So very strange, like I said, that the changes that were supposedly incorporated in runs number 2 and 3 didn't seem to be incorporated in runs 13. So maybe they switched it and found out that it was better beforehand. I don't know. Just interesting going through here. It wouldn't be the first time any of us have found mistakes. So 0.05, someone had replaced the film caps, in the filter film caps, with 2 kilovolt ceramic caps. So I put in what it calls for 0.015 XY2 caps, X1, Y2. The 0.03s that were in here, or 0.003s that were replaced with 0.03s, I replaced those back to 0.03 or 003. What did it call for on the schematic? They were 0.03 and they're supposed to be 003. So I went ahead and replaced those. Everything else seems to be okay. Tested all of the resistors. I think I still need to do the volume control, and I do have one here. A replacement, particularly for this one. It's got the funny Philco partial, a 3/4 shaft, which actually yeah, it is a 3/4 shaft. So that'll have to be swapped out. I may try to clean this one, although like I said, I bought this, so it was only a couple of bucks. I got it from Gary. Tone control is good, switch is good. These big caps were actually almost right on, so I'll leave those. Cleaned up all that. Okay, so what I'm going to do now is I will go ahead and solder these in. I may have to use my little torch / solder ring iron. I had a hard time getting these to melt because there's just so much metal area for my 45-watt soldering iron. So I'll go ahead and get the speaker out, and I'm going to go ahead and get the shadow meter sitting right there, so we can test this out and see if we can create some smoke. Everything so far looks good. I still have to fill the cabinet. I haven't done any cabinet work. The weather's not been all that great here. Oh, and I'll show you, as you can see from the chassis, it looks pretty good. There's a few spots where I had to sand it down and fill it in some more where it had split. I never figured out what was on top of this that caused it to do that. I tried scraping it thinking maybe somebody had sprayed some lacquer on it, but that didn't seem to be the case, so I'm not sure what caused the issue. But since whatever it was that was rubbed in there was down in on the pitting, maybe it was some sort of an oily, you know, there are rust inhibitors that you can wipe on. So I'll go ahead and show you the spot that ripped off down here. I hit with manually with some enamel and a brush. Wish it didn't do it there because it could be hidden if it was anywhere else, but this is the back of the chassis, so I'm going to have to wire the plug back in. I went ahead and ordered, as much as I love these little old Acorn plugs, you know, this really needs to be a polarized plug, and it's got this kind of cool brown cord on it, but I went ahead and ordered a pre-made plug from my friends over at Grand Brass. I was going to order one from what's the other wiring place? Sundial, but their prices have just gotten so astronomical. For an 8-foot cord, they want $27. The same cord is with the plug already attached to it. Obviously I could attach my own plug, but the same cord with the plug already attached from Grand Brass is only $12.50, and it comes with a 12-foot cord on it. So I don't know, I gotta save money where I can, and like I said before, the cloth covered wire looks pretty much the same from either company, although when I get the stuff from Grand Brass, they do have a separate black and white wire for hot and neutral. Although really all that saves me from is continuity check. But anyhow, I'll go ahead and solder these in, grab the speaker, and we'll see what we can get out of this thing. I'll be back. Alright, I soldered the ground straps. I discovered if I turn my soldering iron up to 850 degrees, it soldered quite well. So I was putting the tubes back in, and I realized I came across this tube here. It's supposed to be a 6K5, and it's a 6Q7G. So I went and looked it up, and a 6K5 and a 6Q7, they both are high mu triode, but the 6Q7 has 2 diodes in it as well. The rest of the specs on the triode side are the same, and the pinouts are the same. The difference is that pins 4 and 5 are the diodes, and pins 4 and 5 have no connection on the 6K5. I keep wanting to say 6K7. Anyhow, you know, I did notice when I was wiring this in that for some reason there were extra pins, extra ground for pins 4 and 5 on that particular socket, but I really didn't give it much of a thought. So somebody got a little inventive, which I find kind of interesting, because unless it was just somebody who was lazy, or it was a really long time ago, 6Q7s, when I went to look up a 6K5, because I'm going to have to order one, the 6K5 is actually a cheaper tube than the 6Q7. So I don't know. I'm going to go ahead. The radio was working, as I said, and I don't know how long this tube has been in there. But I'm going to go ahead and I do remember when I tested this, and I didn't think about it then either, because, you know, I'm used to testing tubes with diodes in them, since the detector circuit usually uses them. But anyway, so anyhow, I do remember the diodes on this testing way up in the good area, so I'll have to pay a little more attention when I'm doing stuff, but it's good enough for now to test it. I will order the proper tube. I'm not expecting necessarily to get any sound out of this or tune in very well, because I did remove the mica to clean from here, and although I did count the number of turns, I don't necessarily know that it's going to be good, so we'll find out. Alright, I also don't have any of the shields on here, so I don't know how noisy it will be. So we're going to go ahead and let me go ahead and finish setting this up. I'm going to tilt it up and make sure I'm not leaning on any tubes and whatnot, and I'll be right back. Alright, let's power it up. I did a final wiring check, everything's okay. Again, I'm not really expecting to tune in any stations because of the mica. So let's see if we have any shorts. I think you should be able to see. Maybe if I turn that up a little bit. Well, I don't know. You guys can see better than I can. Well, except when that goes in my eye. Alright, so let's go ahead and turn the power on. It was on. Okay. Let's turn this up to 20 volts. Ooh, I got a little bit of lamp glow. Maybe you guys can see that. You could check the lamp up there. It looks like the rectifier might start to conduct a little bit. I've got some voltage. Let's go to 30 volts. Oh, here we go. And I've got the multi-tester set on the 22 microfarad, the main capacitor there. It should be at 350 volts when it's fully powered. Upside down. At least this one does have voltages. Of course, it doesn't have the voltages for the other caps, but I'll assume if what's going in here is good. Let's take it up to 50. Alright. Take it up to 90. Okay, I think it's peaked up there at 300 and something. Oh, I hear sound. Aside from my neighbor's thumping stereo. Well, let me take it up to 100. Alright, I don't know if you guys can hear that. Let's see, let's switch bands. Ooh. I hear static. I already bottomed out. Well, it definitely needs an alignment, obviously. But I have static. I have 338 volts across the main thing, and I was kind of hoping something would come in. Apparently I didn't count right. I can hear something electrical clicking on and off. Alright, well, I've got power and no shorts. So I guess what we'll try to do here is I'll go ahead and do an alignment. So I'll end this video for now and give it an upload and get this ready for aligning. So I'll have to pull out my signal generator. So thanks for watching, and I will see you in the next video.